The next gas law is Gay-Lussac's law. Gay-Lussac's law deals with variables of pressure and temperature. And temperature, like the other ones, needs to be in Kelvin. So its constants would be moles and volume. So our equation, based off the original, P1 V1 over N1 T1 equals P2 times V2 over N2 and T2. If N and V are constant, they're the same on each side, so they don't factor into this. So our equation for Gay-Lussac's law would be the initial pressure over the initial temperature equals the final pressure over the final temperature. This relationship, as one goes up in this case, the other would also have to go up in order to get the same answer, to get the same constant. So as one increases, the other increases, or vice versa, which means that this is a direct relationship. So let's do an example problem. Number 11 in your packet says a sample of gas occupies 10.0 liters at 114 torr and 27.0 degrees Celsius. Calculate the pressure if the temperature is changed to 127 degrees Celsius while the volume remains constant. So they are telling you volume does not change, so we don't have to worry about writing it. When it says 10 liters, you could write it down, but you can see that it's constant. So our initial pressure is 114 torr, and the temperature at that pressure is 27.0 degrees Celsius. The new pressure is what we're trying to calculate, and the temperature changed to 127 degrees Celsius. Pressure units can be any of the units. All that matters is that your initial and final pressure match. If you're solving for one of them, it's going to be the same as the other unit. And temperature must be in Kelvin, just like Charles' law. So adding 273 to each one would be 300 Kelvin, and I'm going to put a decimal there because that would be 3 sig digs because we're adding and subtracting. We're looking at numbers after the decimal. And for final temperature, adding 273 would be 400 Kelvin. So our equation, P1 over T1 equals P2 over T2. Like before, most students find it easiest to cross multiply to solve. So I'm going to rewrite this as P1 times T2 equals P2 times T1. And solving for P2, I'm going to divide both sides by T1. So the final pressure is going to be the initial pressure times the final temp over the initial temp. Be careful plugging in your numbers. P1 is 114 torr times T2 was 400 Kelvin divided by T1, which was 300 Kelvin. They all have 3 sig digs, so your answer should as well. The answer works out to be 152. Kelvin divides out, so the units would be torr.